Hello friends, welcome to Jija Academy. In today's derivative session, we are continuing from last session. This session we are taking theorem 7, 8 and 9. First one is the differentiation of cos x is equal to minus sin x. So here f of x is equal to cos x and f of x plus h is equal to cos x plus h. So differentiation of f of x is equal to, by first principle, f limit h tends to 0, f of x plus h minus f of x divided by h is equal to limit h tends to 0 cos x plus h minus cos x divided by h. Now for that we are using the formula cos c minus cos d is equal to minus 2 sin c plus d divided by 2 sin into sin c minus d divided by 2. We are using formula in our problem is equal to limit h tends to 0 minus 2 sin x plus h plus x divided by 2 into sin x plus h minus x divided by 2 divided by h. So here minus 2 limit h tends to 0 sin here 2x plus h divided by 2 sin h by 2 divided by h. So here minus limit h tends to 0, this 2 we can write here h by 2, so sin x plus h by 2 sin h by 2 divided by h by 2. This 2 is going to here. So minus limit h tends to 0 sin x plus h by 2 and here limit h tends to 0 sin h by 2 divided by h by 2, and we know that limit h tends to 0 sin h by 2 divided by h by 2 is equal to 1. So we are putting limit here, so we get minus sin x plus 0 into 1. So minus sin x dt differentiation of f of x is equal to minus sin x means differentiation of cos x is equal to minus sin x is proved. Here is now theorem 7 is a differentiation of sin x is equal to cos x. Here f of x is equal to sin x, f of x plus h is equal to sin x plus h. Now differentiation of sin x by is equal to, that is a differentiation of f of x. So differentiation of f of x by first principle is limit h tends to 0 f of x plus h minus f of x divided by h. F of x plus h is a sin x plus h. Minus f of x is a sin x divided by h. Now for sin x plus h minus sin x, we are using the formula sin c minus sin d is equal to 2 sin c minus d upon 2 cos c plus d upon 2. So we are using formula here, so we get limit h tends to 0 sin 2 sin x plus h minus x divided by 2 into cos x plus h plus x divided by 2 divided by h. So limit h tends to 0 sin h by 2 into sin h by 2 into cos 2x plus h upon 2 divided by h. So here limit h tends to 0 2 into sin h by 2 divided by h into cos x plus h by 2. So limit h tends to 0 sin h by 2 divided by h by 2, limit h tends to 0 cos x plus h by 2. So this term is the 1, we know that, so 1 into cos x plus 0, so answer is a cos x. So differentiation of f of x is equal to cos x, so cos x, hence proof. Now similarly for theorem 8, differentiation of tan x is equal to sec square x. So here f of x is equal to tan x, f of x plus h is equal to tan x plus h, and differentiation of f of x by first principle is equal to limit h tends to 0 f of x plus h minus f of x divided by h is equal to limit h tends to 0 tan x plus h minus tan x divided by h. Now here we can write tan x plus h is equal to limit h tends to 0, that is a tan x plus, we can write sin x plus h divided by cos x plus h minus tan x is equal to sin x upon cos x divided by h is equal to limit h tends to 0. Now we are subtracting from this, so we get here sin x plus h into cos x minus sin x cos x plus h divided by cos x into cos x plus h into h. So is equal to, so we know that the formula is sin A cos B minus cos A sin B is equal to sin A minus B. So here A is equal to x plus h and B is equal to x. So we get here limit h tends to 0 sin x plus h minus x divided by h cos x plus h. So we get here limit h tends to 0 sin h divided by h cos x into cos x plus h. So limit h tends to 0 sin h upon h into limit h tends to 0 1 upon cos x into cos x plus h. And we know that limit x tends to 0 sin h upon h is equal to 1. So we get here answer 1 into 1 upon cos x into cos x plus 0. So we get 1 upon cos square x is equal to 6 square x. So differentiation of tan x is equal to 6 square x. Hence proof. If you like the video, please like and subscribe the Jija Academy. Thank you.